Okay, the next topic is summing amplifier. So basically we have three signals or three input values, VA, VB, VC. Okay, VA, VB, VC, those are the three inputs. Now we're going to sum those three inputs in the output. Okay, so here my input is given to the negative terminal, so it's a inverting, so it's going to invert the output value. Okay, now the basic principle, we know that there is no current passing through this, 0 ampere, 0 ampere, and we already know V2 equal to V1. So these are the two important points. As long as we understand these two, sooner it's going to be a lot easier, and it's nothing but solving an circuit with parallel resistors or series resistors, something like this. Okay, so here my V2 is grounded, so we know that V2 equal to V1, this value must be equal to 0. Now at V1 apply KCL. So if I apply KCL, I'm taking IA is coming in here, IB coming here, IC coming from these three inputs. So IA plus IB plus IC equal to, I'm taking this current going out as IF, feedback current. Okay, and here I'm representing this resistance as RF. So IA, I can write this IA equal to, current always flows from high potential to low potential, so this voltage minus this voltage whatever this here, voltage here and here, it's same because there is no element here, so I can take that as V1 and that V1 equal to 0. So VA minus, so IA I can write this as VA minus V1 over RA, IB VB minus V1 over RB, IC VC minus V1 over RC. Okay, and IF equal to V1 minus V0 over RF. So I know V1 equal to 0, so if I simplify this value, it's going to be VA over RA plus VB over RB plus VC over RC equal to negative V0 over RF. I care for V0, so can I say V0 equal to negative RF over RA times VA plus okay, I'm going to have again negative because this negative is going to be applied everywhere, minus RF over RB times VB minus RF over RC times VC. Okay, this is V0. That negative indicates that the output is going to be inverted since we are giving our input to the inverting terminal. Okay, this is summing amplifier. My next topic is differential amplifier. Okay, here is the next example. It's a differential amplifier. In differential amplifier, it amplifies the difference between the two inputs. So I have two inputs, VA and VB. So it amplifies the signal which has difference between these two inputs and rejects any signal common to those two inputs. Okay, so now I'm going to take this voltage as the voltage here as V1, the voltage here as V2, and that's V0. Our goal is finding what is V0. Now first we'll find what is V2. So I know the current going in here is 0 ampere, current going here also 0 ampere, so I can use the current division rule here. V2, if I use the current division rule, V2 equal to total voltage VB times RC over RC plus RB by using current division rule. Okay, I'm sorry, I used the voltage division rule here. Okay, I used the voltage division rule, or you can say there is a IC current going through this, so IC equal to VB over RB plus RC. Once you find RC, V2 must be IC times RC. If you use this is what we're going to end up with, V2. Okay, now I know V2 equal to V1. At V1 apply KCL. So at V1 apply KCL. So if I apply KCL, I'm going to take whatever the current coming here, I'm going to take that as IA, and I'm going to take this current as IF, feedback current. So IA equal to IF, feedback current. IA is nothing but VA minus V1 over RA equal to V1 minus V0 over RF. Okay, so all I care for V0, so can I write V0 minus V0 over RF equal to VA over RA minus V1 over RA minus V1 over RF. Okay, so here we already found V2 equal to VB times RC over RC plus RB. V2 is same as V1, so what I can do, I can equate these two. I can replace V1 with this. Here this is supposed to be V1 there. So V0 equal to minus RF over RC times VA plus, I'm going to put V1 outside. I mean, this became plus because I moved this minus to the other side. V1 times 1 over RA plus 1 over RF. So basically those two are in parallel. Now I'm going to place V2 here. So V0 will end up with minus RF over RC times VA plus VB times RC over RC plus RB times RF times RA over RF plus RA. Okay, this is our V0. I mean, you can see it is differentiating, so VB minus VA. Okay, this is differential amplifier. So in this video we saw summing amplifier and differential amplifier. Now you don't need to remember all these things. All two important things you need to remember is two important things you need to remember is V1 is always equal to V2. V1 is always equal to V2, and there is no current getting inside the amplifier. And apply KVL or KCL at V1 or V2 based on the requirement. Okay, we'll solve some examples in the next video. Thank you.